All right. So we'll get started with our presentation. So first we'll go through the basics of Bitcoin, and then we'll show you a demo, demo on a server that we set up, a full node Bitcoin server, and then we'll go through some detailed topics. So what is Bitcoin? So Bitcoin is a virtual currency that can be used in transactions just like regular currency, and it is totally virtual. There is no, uh, it doesn't have a paper backing, and it is fast and secure, and uh, there are no countries involved, and so it's not just a currency, but it's also a system, and it consists of a peer-to-peer peer-to-peer network of nodes, which maintains a ledger of transactions called a blockchain, and it provides mechanisms that you could use to do transaction validation and currency issuance, and then it makes sure that there is consensus on the ledger uh, in the peer-to-peer system through consensus rules. So using these, blockchain can be leveraged in a distributed way to issue currencies and do currency-based transactions. So there are a few cryptographic techniques that get used heavily in Bitcoin, and the most important of them is public key cryptography, which is explained in this picture. So in simple terms, uh, every participant has a public key and a private key. The private key is something that I keep with myself, but the public key is something that everyone knows. My public key, I can distribute it to everyone. Now, what I do is I can take a piece of text or a number and encrypt using a public key, and I get some blob of encrypted text. And then the only way this text could be brought back to the original form is by using a private key that I hold on to. So nobody else can see hello Alice after Alice has used her public key to encrypt that message. And so that's in a very high level what public encryption is. Hashing is another method in which a text can be summarized by, let's say, 256 bits or 512 bits, where even if you change, so it has some properties like hashes are one-way functions. So once you hash something, it's not possible to bring back the original document or any information about the original document if the hashing is done correctly. And also, it yeah, it yeah, and then digital signatures, what they do is they use hashing and public key cryptography in a way such that you can construct messages that cannot be tampered, so by putting a signature on it. So the way you put a signature is generally by taking a hash of the message and then signing it with uh, your private key, and that way everyone else has the person's public key, so they can just decrypt and see that it's the correct hash, but they don't have the private key. So if they change any part of the document, then they cannot, then the digital signature would not match the hash. So using this, you it can be proven that a signature that a message was signed by a particular user. And Bitcoin addresses are pretty much public keys in the public key cryptographic method, and they can be uh, and and they become Bitcoin addresses. And please let us know if you are having any difficulties in the audio or the video. And what is a wallet? A wallet is what a user keeps to maintain his keys. So a wallet is what maintains a user's public keys and private keys, and a wallet controls access to his money. Uh, it 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 tracks the balance and creates transactions. One thing to note is that a wallet does not contain bitcoins itself. A bitcoin is held in the blockchain, but a wallet contains all the keys to be able to access the blockchain. So let's go to. So you can check the price of a bitcoin by going to some websites, and it will tell you the US dollar conversion for bitcoin. And a transaction is a transaction in a high level is a double entry bookkeeping transaction where input one where there could be multiple inputs and multiple outputs, and the inputs contain some value in bitcoins, and similarly the output contains values in bitcoins, and then there is some total input and there is total output, and the difference of the total input and the total output is what the Bitcoin network takes in order to maintain the infrastructure around it. So this is the transaction fee, and so on the right you can see how a transaction behaves. So a the first transaction, Joe sends Alice. He uses his 0.1005 bitcoins to send a 0.1 bitcoin to Alice, and the remaining 0.0005 bitcoins become the transaction fee. Then Alice can use the 0.1 bitcoin to send to Bob 0.015 bitcoins, but she can only spend the whole output in one go. It cannot be in fractions. So the way to, if she wants to pay Bob something less than 0.1, then she will pay herself back the an amount, and then there is some transaction fee. So this is the second one. And similarly, when Bob receives 0.015, he can pay Gopesh 0.01 Bitcoin, and then he pays himself back 0.0045, where 0.0005 Bitcoin becomes the transaction fee. So this is at a high level how Bitcoin transaction looks like. So a Bitcoin transaction, there is a thing that the output has to be used in its entirety. So in any output, so if you see this output, which 0.1 Bitcoin that went to Alice's address, has to be used in total entirety. It cannot be used as a fraction. So so for example, if I have very small Bitcoins, but I have to pay a bigger Bitcoin amount, then I can aggregate a bunch of Bitcoins to create a bigger output. Similarly, if I have to pay a smaller amount, then I take a change back generally. Or if I have to pay multiple people in a single transaction, or then I can also use one big output as input, and then pay multiple people in a distributed transaction. So how do you construct a transaction? So first of all, it finds enough outputs or unspent transactions in the blockchain that belong to the person who's trying to make the transaction in the wallet, and then the output. Then the output is basically a script, and the script basically says that this output can be used by anyone who can present a signature or present the necessary proof that the script needs. And and there could be another change transaction, and whatever is the difference between the input in this transaction and the output that is desired by this transaction is given back to the network as a transaction fee. So that's how we would construct a transaction. So how would we send a transaction? The way we would send a transaction, because it's a peer-to-peer system, it's basically we construct the transaction, and then the transaction is flooded to its own peers. A node will send it to its own peers, and then by a process called Bitcoin mining, the transaction can be becomes a part of the blockchain, which is the ledger, the distributed but one ledger for blockchain, for Bitcoin. So Bitcoin mining is Bitcoin mining has multiple functions. One is that it makes sure that the transactions are correct, rejects malformed transactions, and it the way it works is it also releases new coins. So every time someone wins a round of mining, then he gets a certain number of new Bitcoins that are released into the system. So, and all the transactions that are coming in are bundled into a block in every node, and the winner of the previous round creates the candidate block and puts the first transaction in the block, and then the competition goes on, and it is the target of the competition is that someone would win the competition every 10 minutes, and then the Bitcoin mining competition goes on, and someone at the end of 10 minutes or before or a little after can come up with the next block that fulfills all the criteria. And because this is very computationally intensive, once one blockchain is accepted into the ledger, and as time goes by, it becomes very hard for someone to recreate 4 or 5 or 6 rounds of these computations. So as time goes by, the ledger becomes more and more stronger. So the first transaction after a number of transactions becomes very hard in the peer-to-peer system to change. So you can we'll go back to we'll go back to running this on the server. So we created a server for you where it is connected to a full Bitcoin node, and you can query the server. So let's go and check how that works. So we sent you instructions. So we'll have the server running for a few days, so you can go back and check. And if you can, you should be able to log in and connect to this. So let's see here. So this uses basically the way you communicate is through a JSON RPC protocol, and there are Python libraries and Node libraries and all sorts of libraries written to do so. So here we will use the Python library and mostly curl to be able to query the Bitcoin node. So here in the first snippet, what we are trying to do is in this snippet, what we'll try to do is so when you run the Bitcoin node, so it can be a full node or it can be a partial, but full node takes a lot of it takes a lot of resources, so we could only do a partial node. And for the partial node, has most of the blockchain, but not all of it. But we could configure it. And so if you see, when we query info about the node, the most important things are what protocol version, what Bitcoin protocol version it is running. Also, what block number it is, which is what is the highest block that this node has seen so far. So this particular node has seen block number 447373. And if you see, there is a difficulty level, which is what was given in order to when people were mining it. So so depending on the difficulty, it takes more or less time to mine the Bitcoin. And then the same thing can be also you could also query it using curl. So using curl, you can query this Bitcoin server, and it will give you a similar result. Also, wait, this is, oh, okay, this is the wallet and not info version. Oh, this is actually something else, but yeah. So now we'll see how the transaction looks like. So we'll take a transaction and we'll try to decode how it looks like. So if you see, this transaction in the blockchain has a transaction ID of, this is the transaction ID. Then these are the inputs. And the inputs are coming from this transaction ID. So this input is the output of this particular transaction. And this is the signature that this transaction gives, which means that by using this script signature, the output script of this transaction ID that corresponded to vout0 can be satisfied. We'll see more of that in a little bit. And then, so this kind of says that I'm the correct owner of this previous transaction. And then that person distributes it to multiple public keys. So multiple other wallets. And the way to do that is a vout and a script. So this is the script that whoever can satisfy the script can get the 0.015 Bitcoins. And similarly, the 0.0845 is given back to whoever can satisfy the script. And if you see, these scripts are basically satisfied by the script signature in the next when they actually get to use. So let's get to, so that was a transaction. So now let's see how the block looks like. And so block is a collection of transactions. So if we query what a block hash is for block number 420,000, then this is the block hash. Now we can query the block hash, and we can see how the block looks like. So a block, the most important things are, in a block, there is a set of transactions. So all these transactions belong to this particular 420,000 number block. These transactions were part of that block. Also, and the difficulty of the block, like we were talking before, is like can control how much time it takes to compute this, to find this block. And also, Merkle root is a way to to be able to update hashes in log n time by using a Merkle tree, and that's the root of the Merkle tree. And this nonce, so everything else in the block is constant. The only thing that the miner does, that the Bitcoin miner does, is change this nonce in order to get different hashes. And the difficulty is, you can think of the difficulty part of the blockchain as, if, for example, if hashes are between 0 and 100, and if I say that I have to find a hash between 0 and 5, then it's very difficult. But because if you put nonce as any number, there's only a 5% likelihood that the hash will be between 0 and 5. But if you keep changing, if you put hash as anything less than 95, then any nonce you choose, there's a 95% chance that the nonce will be acceptable. So you can choose the difficulty of creating a valid block by choosing what's the maximum hash could be, and then the miners determine what nonce would work for it. So what random number would be able to satisfy this condition, and whoever does that wins that round and gets to pick some Bitcoins. So next one is how to do. So this one we are trying to. So this one is how we are trying to. What are the other nodes that this particular full node or partial node that we are running is connected to? So this will show you what are the blocks in flight, and also what are the other servers that we are connected to. Yeah. Okay. So now we'll come back to our presentation and go over. So you're encouraged to go into Data Cabinet and play around with it and see how the blockchain server works by using the JSON RPC curl commands. So now let's go to some details on how things work. And so one of the questions could be that if I distribute my public key, would someone be able to track me given the whole ledger is public information? But that's not the case, because my wallet can have a lot of different public keys, and the only time I need a public key is between output of a transaction and the input of the next transaction. I could use a different key every time. So that way, even if someone knows the whole ledger, they cannot really pinpoint that this particular person did this transaction. To maintain multiple keys, you can have like a non-deterministic way where you just maintain hundreds of different keys, or you could have a deterministic way of doing it, which is you basically create a seed, and the seed basically determines the random number generator, and then the random number generator determines which are the next public key and private key pairs that will come up. So you can create a number of public and private key sets, but they will always be the same depending on the seed. So how do I explain? So if you set a seed of 42, then the first public key and the second pair and the first pair and the third pair, they will always be the same numbers. So that's deterministic. And HD wallet is a deterministic wallet that has a tree structure imposed on it. So when you impose a tree structure on it, it becomes, you can do other things like it's easy to query, and also you can have organizational structures on the tree. So that's how wallets keep keys. So all the most important thing to track in Bitcoin is unspent transaction output, which is also known as UTXO. So if you think about it, the only thing that can affect the next transactions is the unspent transaction output, because those are the active currencies with people. And in the Bitcoin world, if you think about which came first, input or output, outputs came first because the first transaction was basically an output transaction that did not have an input. And okay, so I think we, yeah. Okay, let me. So this is how. I'm trying to see if I can. That one has exceeded that space. Yeah. So this is how UTXO looks like. This is basically the V out of a particular transaction, and it also keeps a script, and whoever can satisfy the script, they can use this value. And in this particular example, this transaction has 2 UTXO. And similarly, transaction input contains the transaction ID of the previous transaction that generated this input, as well as a script signature, which says that I own this output because I have these numbers with me. And this is basically a signature most of the time, where this transaction has been signed by the private key of the person owning the previous output. So then nobody else can sign it, and everybody else can everybody can verify, but nobody can actually sign it other than the actual owner. So this way we can determine that this is the correct owner of the previous output. Also, transaction fees. So the way transaction fees are determined, how much transaction fee would be charged, is dynamic, and it's controlled by per kilobyte. And if you put a transaction where the fee is too little, then miners will not actually bring in and verify those transactions. But if it's too high, then they will prioritize it and put it in the next block. So there are websites which will tell you what is the current fee and what are the fees at which mining is possible. And you can some wallets even query those websites before constructing a transaction. So this is a nice one where it says, so how the transaction output script that we have been mentioning is in itself like a programming script, but it's not. It's a reverse Polish notation stack based execution, which makes sure that you cannot inject a loop and put the Bitcoin miners in a loop and waste cycles. And the most commonly used script is the pay to public key script that we have been seeing. Which public key is basically the address of a person, and then the transaction output script basically says pay to the person who has this public key. So let's see how it actually works. So this is the script that we have been seeing. If you see the script here, then so this is something like this script. Top hash. So this is this script. So how the script actually works is something will show in this slide. So the script begins with a signature, then a public key, then the stack moves to the next execution pointer, a duplicate, which duplicates this public key. I think it got curtailed, but okay. So then there is a hash computed for this duplicated public key. So then you will have a hashed duplicated public key. Then then it will be then a public key hash will be put on this stack. Then equal verify will be will make sure that the public key hash is correct, and then the check signature will check the signature that this signature matches the signature. And then when check signature finishes, it puts a true value in the stack, and that says that the transaction output script was correct. So let's delve into what are the components of the peer-to-peer system that drives this blockchain. So in a full node, we have everything. So there's also a wallet, or other people can connect their wallets to a full node, and okay, and then there is a miner which goes through the blocks, make sure the blocks are correct, make sure the next the new blocks are coming through, and of course there's the blockchain, which is the data itself, and then there is network routing, which is where the other nodes are and how to connect to the other nodes. And but these are the important ones, but there are some. So this is what a full node will consist of. But there is also a simplified payment verification system, which doesn't. If you are not running a full-fledged server, then you might want something simpler. And so we have a slide. We'll come to the simplified payment verification system. So BitCoin relay servers are Bitcoin. The miners are do a very time sensitive thing. The latency matters. So what they want to do is they have relay servers that are that basically optimize latency, and then miners can work on the relay network. But they are not a substitute for the peer-to-peer system that the nodes built, but they are more of a service for the miners, so that they can do the time sensitive work. And so this is how the full network will look like. So some of the important things to notice are here. There is a pool server, which is driving a bunch of mining nodes, and this is a relay server, and these are full nodes, and these are solo miners which are not wallets. And so then there could be other protocols like Stratum also running in conjunction with Bitcoin. And yeah, and then there are wallets that are communicating with the whole system. So how does a Bitcoin node, when it initially comes up, how does it find peers? So basically there are some DNS seeds, and those DNS seeds can provide a list of static IP addresses, or by using bind, they can also be dynamic list of IP addresses that we can get, and then we can query those peers, and that's how a node can get started. And, so the way a Bitcoin node syncs up with the latest blockchain is by using this message called inventory. And in the version message, there is a report on how large the inventory is, and by sending inventory messages through its peers, you can get the most latest blocks and update your blockchain. And they are using UDP, and so UDP you can clock the network. So they do their own flow control, so that there is only the other peers on the network are not overburdened. So there is this SPV nodes, which are which we just discussed as the simplified payment verification nodes. these nodes are not running a full version of your blockchain. So how do they make sure that they can validate a transaction? They can take parts of the transaction that they need to validate, and they can ask some other node whether about which of the outputs contain this particular public key, or and which of the so that. But the thing is, so they can ask these questions to the full nodes, but there is one. Yeah, so the only relevant points of yeah. So also these SPV nodes only download the block headers and not the actual transactions themselves. So they can handle the smaller traffic. So, and also the way they will ask others, they might be revealing information about themselves. So if someone is running a wallet with a SPV node, then what could happen is they are not. Someone could monitoring the network could figure out that whose transactions are these. So who could figure out in the blockchain all the transactions that the person has. So they use this thing called Bloom filters, where they don't really bring in everything that they own itself, but a lot of other transactions as well, so that a person monitoring the network has no idea of which ones actually belong to this wallet. So now let's come to blockchain itself. So what is blockchain? A blockchain is basically a list of transactions that are ordered, and they all have a backlink to its parent. And the way it is backlinked is basically every transaction has a hash of its parent, and each transaction can only have one parent, but it can have multiple children. So in the peer-to-peer system, some multiple nodes could be computing children that they think this node is the parent of, but ultimately one of them will win, and the others will be discarded. And but the good thing is that because each node has a hash of its parent, if you change even one node a little bit, then its hash will change, its children's hash will change, its children's hash will change. The whole blockchain will need to be recomputed. So because of this, you can be sure that the blockchain has integrity, that the blockchain, especially the blocks that have been used, like that have been confirmed like a while ago, cannot be changed. So that's the good part about blockchain and why it can be used. So let's get to the structure of the block. As we saw in the code, that a block consists of a transaction counter, how many transactions, and the hash of the transactions themselves, and a block size and a block header. So the block header is the interesting one. So the block header, I think we went through it in the code as well. This is the way. The two important ones, the previous block hash, of course, like we were just talking, and then the two good ones are nonce and difficulty targets. So nonce, the way you can change nonce, and the whole hash of this block will change. And the difficulty target is basically, you can think of it as a number that the first person sets, the person who won the previous round of mining sets, and the miner has to make sure that the hash that it gets is less than the difficulty target. So this way you can have, and the idea is that every 10 minutes someone should win. So this way you can keep adding blocks one on top of the other. And Merkle root is basically a Merkle tree, which consists of hashes of children and parents, and of all the transactions. And this makes querying the hashes easier. Querying and updating the hashes easier. And Genesis block, this is the first block hard-coded in the blockchain. So the first block that was ever used in blockchain was hard-coded into it, and it's called the Genesis block. You can still, if you run this command on a full node, you'll get it. We couldn't get it because we couldn't hold the whole full blockchain. But here you can find the information about it. So that brings us to the end of our discussion. And please do not forget to sign up, and we'll keep sending you new technologies as we discuss them. Thank you. Please let us know on if you have any questions. On the code as well as on the presentation. Okay, well, there's none. We'll finish the event and then look forward to the next one.